Hi and welcome to this video 1 of Unit 4 Topic 5, and in this unit we're looking at, or in this topic we're looking at sampling and confidence intervals. And so we're going to start by talking about sampling, and in this video we're going to be looking at some particular definitions and some early examples of what sampling is and how it might affect what we're working on. This part of the topic will be split into 2 videos. So first of all, learning goals, success criteria, etc. Now let's have a look at the content. To collect data, there's some things we must consider. Let's first recall some common definitions. So firstly, a population. A population is every element in a set. So everything that belongs in the group that we're referring to is part of the population. Not everything is in a population, but it could be people, it could be objects, it could be things. If it's people, it might be the population of the world, but it might just be the population of Australia that's important to us, or maybe the population of Queensland only, or perhaps even just the population of your school, or even your family. It depends on what the frame of reference is that defines a population. A census is a collection of data from the entire population, so where you collect data about everything in the population. So if we're talking about koalas that are currently living in the Gold Coast hinterland, well then we would have to get information about every single koala for that to be considered a census. On the other hand, a sample is if we took some data just from a proportion of the population, just some of them. And so obviously the benefits of a census are the accuracy of information. The benefits of a sample are the speed and the cost associated with taking a small amount of data. And then of course that might not be quite as accurate, but hopefully we can use it as a good predictor. A sample size is often called N, and it's just the number of elements in the sample. So you might collect data from 10 people in your school and your sample size would be 10, whereas your population size would be the number of students in the school. Now, in this case, I've called population P in this little definition I've put down here. It's very arbitrary. We don't really have a way of defining population size, but it is well recognized that your sample size should be at least equal to or greater than the square root of P. Now, it sounds a little bit scary, but if in your school you have 1,000 students, well, the square root of 1,000 is about 32. And so if we're talking about 32, 33, if we're talking about 33 students being a reasonable sample from 1,000, that's actually not too bad, really. Now, the whole purpose of a sample is to collect data that we hope we can use to model or understand the population statistics. So, of course, to do that, we'd like to avoid bias. Now, bias is something that is a name we give to a situation where data might be skewed in one direction or another. So, for example, if you wanted to collect the opinion of students in a school about a uniform change and you only ask girls or you only ask boys, that might present an opportunity for bias. So you've got to be considerate of that when you're collecting your sample. And here's another example. Imagine if you went across to the new Cooma Westfield, and if you don't live near here, it's just a shopping centre, and you asked people at random in Cooma Westfield where they preferred to buy their groceries. Now, the thing about Cooma Westfield is it currently has a Woolies and a Coles. It does not have an Aldi, an IGA, or any other supermarket type chain. So if you're asking people in a particular shopping centre that only contains some of the options, they're actually likely, or somewhat likely, to be there to visit these stores, which would make them Woolies or Coles shoppers. So it skews the data. And let's take it to the extreme to make it really obvious. Imagine if you stood outside of Coles and as people walked out, you asked them where they prefer to buy their groceries. That's going to obviously present a set of information which probably says most people prefer to shop at Coles. So you've got to be very careful about where you collect your data from to avoid that bias and skew in the data. And not just where, but some other elements as well. So there's lots of different ways we can collect samples, and these are called sampling techniques. And the first that I'll talk about is convenience. A convenient sample is just about collecting a sample that's the easiest to collect. So you might be doing a survey for a class project about the opinions of 16-year-old students, And the convenient sample would be to ask the students in your class. That may not be representative. Your school will have a demographic, it is in a location, so there will be some bias there, but it might be convenient to you rather than asking 20 people randomly across Australia. So that's a convenient sample. Convenient samples can very easily lead towards bias though. But a sample is there to save time and money, so it is something that's often considered. A stratified sample is much better. So a stratified sample is where you take a sample, but you're considerate of the proportions within the population, usually the proportions that matter. So if we're talking about school-age students from year 7 to year 12, so a secondary school context, and we want to ask a question about uniform policy or something to do with that, you might consider it reasonable that within your sample of 30 students, you ask percentages that line up with each year group. So 30% of the school are year 7 students. Well, you would ask 30% of 30, which is 9, so you'd ask 9 students from year 7. And that stratifies it, so you've got the proportions right within your sample that match the proportions within the population. So that's quite a fair way of taking a sample once you've chosen your sample size. A systematic sample is another way of taking a reasonably random sample, and that would be where you might take all the students in your school, put them into an order, and allocate that order a number, and then you take every third person or every 10th person in that list. That would be a systematic way of doing it, and would allow you to ensure you pick the number of students that you want in what looks to be a fairly spread out way. Or of course, there is the random sample, which is what we're going to be mostly talking about today and in this topic. So a random sample is where you allow no bias or opportunity for your choice to affect the sampling. So this would be, in the commonly used terminology, would be you ripping up everybody's name on a sheet of paper and putting it into a hat and pulling them out of the hat. Of course, we have more technological ways of doing it nowadays, and we usually use random numbers from a random number generator. And on page 657 of the Cambridge textbook that we use, you'll see some information about how to use the Casio calculator that we use to generate lists of random numbers, which I will show you in a minute as well. So example 1, when might a census be more appropriate than a sample? And so we talked about this briefly earlier. And of course, a census is more appropriate where you need the actual data. Whereas a sample, maybe you don't necessarily need the actual data. So here's an example of a good time to take a census. The government allocates money to schools based on lots of different factors, including demographic, the number of students, and the student background, family situations. Sometimes it's based on suburbs and the suburbs listing within how well how the equity and the money is going in that suburb. Sorry, I'm struggling for words there. So that's something that's important to the government there. If they just took a sample of schools, so say they collect data from just 20 schools, and they might randomly choose 3 of those schools from Queensland, and then just look at those 3 schools and go, okay, well, the average number of students in those 3 schools, which just happen to be regional schools, is 226. And I go, well, we'll give every school enough money for 226 students. That obviously wouldn't be a fair model. It wouldn't be representative. In this case, for the allocation of funds to schooling, it's really important that the government is looking at every single school and their particular situation. Whereas a sample might be appropriate in a case that we're asking the opinion of school principals on changes to the NAPLAN exam, and maybe collecting data from every school principal would be ideal, but it's not possible in the time frame. But there's no financial reward riding in it. There's no importance that schools are getting something out of it at the end. It's just an opinion-based thing, and so taking a sample of 50 or 100 might be just as appropriate. Example 2. Now, I've arbitrarily done up a list of students. There are 26 of them. I'm going to zoom out so you can see them all. And you'll see that I've been what I think to be quite clever. And I've started them all 26 with each letter of the alphabet. So of these 26 students, I want to take a sample of 5, a random sample of 5. And I did this earlier with a class. I'll just cut this. So you'll see the results, and you could pause there and have a look at that and see that if we do one now, it might be different. and I've highlighted the people that I've randomly chose, so I'll just rub that out. Now, if my random sample of 5, I'm going to use a random number generator to get that random sample of 5. So I've listed them all, I've given them numbers, and I'm going to go to my calculator to do that, and I'll show you how to do that now. So if we go across to our calculator here, to do a random set of numbers, first we need to go into our option menu, and then we go across F6, probability, F4 for random, and then we can do, there's a few different random opportunities here. I'm going to just show you first of all just random number. The random number just gives you a number back that is between 0 and 1 to a certain number of decimal points. It's really random. Now you can bulk that number out. It'll be basically continuous. It's obviously rounded to some point, but it's basically continuous. So if you wanted the number between 0 and 10, you just multiply this number by 10. If you want a number between 5 and 15, you multiply it by 10 because that's the range, and then you add 5 to it, and it will always be between 5 and 15. So if I press execute there, it just gives me that random number to 8 decimal places. But what I want is 5 random integers. Now I'm going to choose F2, which gives me random integers. I'd like my 5 random integers to be between 1 and 26, and I'd like 5 of them. So I'll press execute there, and that gives me my 5 numbers. Now I've actually hit a pitfall here, which is an important point to make. Once I've chosen student 22, I don't want to choose student 22 again. So I need to repeat a sample to get a new student to add on instead of 22. So I'll just do this random int, and I'll just make sure of it, 1, 26, and just in case I get a repeat number again, I'll pick 2 more numbers. And this time I get 11 and 21. So I'll ignore the 21 and I'll use the 11. So I'll just grab a screenshot of this situation, and I'll pop it onto here so you can see it. And so here is my random numbers, and I'm going to choose 5, 4, 22, 1 and 11, ignoring the second 22. So 5 is Eleanor, 4 is Donald, 22 is Victoria, 1 is Alan, and 11 is Katie. And so we've actually ended up with the same distribution as I had last time, and that is that I have my males, I have Donald and Alan. So I have 2 males, and females I have Eleanor, Katie and Victoria. That's 3. So that's the end of that example, and that's how we take a random sample or a random set of integers from our calculator. All the best.